Hello everyone, welcome to my channel Physics Tricks. So in this video we'll do theory of kinematics and some problems related to kinematics. Okay, so in this we have equations of motion of a body moving with uniform acceleration, and the starting part of the kinematics which I gave in the other video. If you wanted to see that, you can go into the description and click on that link. Okay. So we have equations of motion of a body moving with uniform acceleration. In this first equation of motion we have first equation of motion, and we can actually calculate this first equation of motion by using the graph over here. As you can see, this is the graph. We have, this is the time axis and this is the velocity axis, and let us consider initial velocity of this is u and the final velocity is v. So here we have initial velocity u and the final velocity we have is v. So over here final velocity is v at time t is equal to t only. So over here we have the slope. Let us consider theta. We have tan theta is a slope, initial point 0. So if you just take the slope of this line, right? So slope of velocity time graph gives acceleration. That indicates what? That indicates from slope of velocity time graph we can find out the first equation of motion, right? So over here slope, as you can see, the acceleration, and that a is equal to tan theta, and that tan theta we can write as this divided by opposite divided by the adjacent. What is the opposite side over here? This is v minus u. So total is v, as you can see over here. This total is v and this one is u. So if you just subtract v from this u, you will get v minus u. So I hope this is clear. So this is v minus u divided by, what is the adjacent side? This is t minus 0. So that is t. So from this, as you can see, we have v is equal to u plus at. This is the first equation of motion we have. This is the first equation of motion we have. So I hope this is clear now. It's very simple. V is equal to u plus at. Now what is this v, what is this u, and what is this a and t? V is final velocity. That is what you have to remember. Okay, now so it's like if a body starts from rest and moves with a constant acceleration for 2 seconds, and that acceleration value is 2 meters per second squared, find the final velocity, they might ask you, right? So in that case you have to calculate the final velocity. Initial velocity, as the body at rest, it will be 0, right? Uniform acceleration, these equations are valid only for uniform acceleration. Uniform indicates constant. Okay, so what is u over here? U is initial velocity. U is initial velocity. What is a over here? A is acceleration. A is acceleration, and t is general time we have. T is general time we have. So I hope this is clear. So this is the first equation of motion we have. First equation of motion we can calculate by using the slope of vt graph. Okay. So next, second equation of motion. So second equation of motion we can calculate by calculating the area under velocity time graph. Okay. So if you take area under velocity time graph, then that area gives what? Displacement, right? So displacement S is equal to, that is the area under velocity time graph. So that is area of triangle we have, right angle triangle, plus area of a rectangle we have. So I hope this is clear. So over here, as you can see, this is the right angle triangle. So this is the graph which we have. Under this, whatever the area is there, that area you have to calculate. So as you can see, we have the triangle, and triangle I'll take over here. This is, let us consider x, this is y, this is z, and this is, let us consider, we have p. Okay, so in triangle xyz we have a area as half base into height. Base is t, height is v minus u. So I'm taking over here, so it is half, base is t and height is v minus u, plus what is the area of rectangle over here? Rectangle area is the length into breadth. Length is t and the breadth is u. So u into t we have. So I hope this is clear, right? Area of triangle plus area of rectangle, which is equal to ut plus 1 by 2 v minus u into t. From the first equation, so I'm writing over here. From the first equation we can have, we have v minus u is equal to 80, isn't it? V is equal to u plus 80 indicates what? V minus u is equal to 80. Put this 80 value over here and you will get ut plus 1 by 2 80 squared. That is what the s is, displacement is. Okay, so this is the second equation of motion which we have. Now what is s, what is u, what is t, what is a? Yes, over here, yes is displacement which we have. Then what is u? U is initial velocity. What is a? Acceleration. And what is t? Time. So I hope this is clear, right? So these all are the equations of motion, we can say, right? So these two are the equations of motion. Now third equation of motion, we can calculate the third equation of motion by rearranging the first equation and the second equation. So you can write, by first equation, we have v minus u is equal to 80, and from this, what is time? Time is v minus u divided by a, and from second equation, and that is s is equal to ut plus half 80 square. Now you can put this t value in this and you will get, put t is equal to v minus u divided by a in s, then we'll get s is equal to u in bracket v minus u divided by a plus 1 by 2 a v minus u divided by a whole square. Now take v minus u divided by a common. So it is v minus u divided by a common. It will be u plus 1 by 2 a in bracket v minus u divided by a. So this get cancelled, and we'll get, this is v minus u divided by a multiply with, this is u plus v by 2 minus u by 2, and if you just calculate, v minus u divided by a into, this is u minus u by 2 is u plus u by 2, so v plus u divided by 2, and we can use here one formula, a plus b into a minus b will get a squared minus b squared. So put this over here, you will get v squared minus u squared divided by 2a, so we'll get v squared is equal to u squared plus 2s. And this is the third equation of motion which we have. This is the third equation of motion which we have, right? So first equation is v is equal to u plus 80, second equation is s is equal to ut plus half 80 squared, and third equation is v squared is equal to u squared plus 2as we have. So I hope all these equations are clear to you all. Now from the second equation of motion, we will have one corollary, and that is the displacement in the nth second, right? So by rearranging the second equation, right, we'll get the fourth equation we have, and that is the Snth, that is displacement in nth second. So it is just these three are the main equations of motion, and the fourth one we have is displacement in nth second, that is just the corollary we have. So now I'll take displacement in nth second. Before that, if you want this third equation of motion, right, third equation of motion, by other formula also we can find out, and that is by using the V average formula, right? And what is that V average formula? See, V average we have is equal to total displacement by total time. And what is total displacement? It is ut plus half at squared divided by time t. So if you take t common and cancel it out, you will get 1 by u plus 1 by 2 at, that is s divided by t. So what is u plus 1 by 2 at? U plus 1 by 2, what is at? V minus u. And if you just find out this, you will get v plus u divided by 2, that is s divided by t we have, s divided by t we have. So therefore I can write v plus u as 2s divided by t and v minus u as at. Now if you just multiply these two equations, we'll get v plus u into v minus u is equal to 2s divided by t into at. So as you can see over here, this equation and that equation is same, because it is right over here, right? So it is v squared minus u squared is equal to 2as, right? So you can directly find out, right? V average, if you know, you can directly find out. And yes, the main thing over here is note, and that is these equations are valid only for uniform acceleration. Uniform acceleration means what? Constant acceleration. Okay, uniform acceleration. Second one, for uniform acceleration, for constant acceleration, you can have the average velocity as the total displacement by total time. Displacement formula, you know, ut plus half at squared divided by t, which is equal to u plus 1 by 2 at. But at we know, at is v minus u, so put it over here, v average, and that is equal to s by t, which is equal to u plus 1 by 2 v minus u, so which is u plus 1 by 2. What is v minus u? V minus u, you can actually have this as v divided by 2 minus u divided by 2, which is u by 2 plus v by 2, that is v plus u divided by 2. So this is the v average which we have, v average, and therefore s divided by t, total displacement by total time, is v plus u divided by 2. So this is one more formula that you need to remember. Okay, now after this we'll do what is called as the displacement in nth second, right? So see here, we have now what is the displacement of a body, in nth second, displacement of a body in nth second. Okay, now so over here, now what is this nth second means, right? So displacement of a body in second, displacement of a body in third second, displacement of a body in 4th second. What does this mean? See, if I wanted to calculate the displacement of a body in 5th second, supposed to be, now what I need to do is I have to calculate the displacement of a body in 5th second, right? In 5 seconds, right? So this is the 0 seconds which we have, this is the 1, this is the second displacement, this is the 3rd, 4th, and supposed to be 5th. This is the 5th, suppose. So I have to calculate firstly, right? I have to calculate firstly the displacement of a body in 5 seconds. And if I just subtract this displacement from the 4-second displacement, isn't it? 4-second displacement, I'll get this displacement, and this is called as the 5th second displacement. What is 5th second displacement? From 4 seconds to 5 seconds, whatever displacement is there, that is called as displacement in 5th second. So over here, displacement in 5th second is equal to displacement of a body in 5 seconds plus minus displacement of a body in 4 seconds, right? So this is what the displacement of 5th second mean. What is the displacement of 6th second? Displacement of a body in 6 seconds minus the displacement of body in 5 seconds. That indicates what? That indicates, if we consider the body which is moving in with a uniform acceleration, and this is the first second, this is the second, this is the 3rd second, and likewise this is the n second supposed to be, and this is n minus 1 second. So what we need to find out, we need to find out what is the displacement of a body in nth second, right? Nth we need to find out. So for that, what we have to do, we have to firstly calculate what is the displacement of a body in n seconds, displacement of a body in n seconds, and subtract this displacement with Sn minus 1, isn't it? N minus 1. So if you subtract this Sn minus 1 from this Sn, you will get Snth displacement, isn't it? So Snth displacement we have is S of n minus S of n minus 1. So I hope this is clear now. Now what is S4 or S5 and S4 over here? S5 indicate displacement in 5 seconds. So U into 5 you have to consider, plus 1 by 2 A into 5 squared you have to consider. And S4 indicates U into 4 plus 1 by 2 A 4 squared you have to consider. Over here we have considered Sn, right? Displacement of a body in n seconds. That indicates instead of time you have to consider n over here. So instead of time t, you have to consider n over here. So I'm writing Snth now, and that is equal to Sn is un plus 1 by 2 a n squared. This is Sn we have, minus, what is Sn minus 1? Instead of time t, you have to consider n minus 1 over here. So n minus 1 plus 1 by 2 a n minus 1 whole squared. So if you just find out now, un plus 1 by 2 a n squared minus un minus 1 minus 1 by 2 a n minus 1 whole squared. Now that is equal to, so un, now just open this bracket, it will become un plus u minus 1 by 2a. Now simplify this, it will become n squared minus 2n plus 1. So if you just cancel it out, you will get this 1 by un get cancelled, so you will get 1 by 2 an squared plus u minus 1 by 2 an squared, and this plus 1 by 2 a into 2n minus 1 by 2 a is the expansion of this. So you will get this 1 by 2 a squared, 1 by 2 a squared get cancelled, u plus 1 by 2 a common, 2n minus 1, and this is the displacement of a body in nth second. So as you can see over here, this side is the displacement, right? This side is the displacement, and here as you can see, this is the initial velocity. Now why this side, and in dimensional formula we have seen, if this side, like left hand side is force, right hand side we can equate it with always the force only, right? So this kx supposed to be, this is, must be force, isn't it? If left hand side is momentum, right hand side must be momentum, right? Equal to, right hand side must be momentum, like p naught, right? Now so we can equate momentum with momentum, we can equate force with force. Then over here what happened, why displacement is equal to initial velocity, right? So why we are equating this, that means initial velocity must be equal to this is velocity we want, right? So why this is initial displacement which is equal to initial velocity? If you know the answer, please comment in the comment box and I'll reply to your comment. Okay, so this is the question for you, and please comment if you know the answer. Okay, chalo. So this is the displacement in nth second which we have, that is u plus 1 by 2 a and 2n minus 1. So what we have seen, we saw first equation, and that is v is equal to u plus at. Second equation, that is s is equal to ut plus half at squared. Third equation, v squared is equal to u squared plus 2as. Fourth equation, that is snth, this is just the corollary of second equation, snth is equal to u plus 1 by 2 a 2n minus 1. So these are the four equations we have, and as you can see over here, we can equate this with a vector form, right? We can equate this in a vector form, like v bar we have, that is equal to u bar plus a bar t. Then s displacement bar is equal to u bar t plus 1 by 2 a bar t squared. Then v bar dot with v bar is equal to u bar dot with u bar plus 2 a bar dot with s bar, right? So these three equations are in the vector form, so if you want you can write these equations in the vector form we have. Okay, so I hope this is clear to you all. Now we'll do some questions based on this, right? So write down one question, and that question says, a car starts from rest and moves with uniform acceleration of 0.5 meter per second squared for 2 minutes, full stop. Find the velocity acquired by car. Find the velocity acquired by car. Okay, so see here, it is given a car starts from rest. So firstly understand the question very carefully. It is given car starts from rest indicates initial velocity of the car is 0. So u must be equal to 0 meter per seconds, and moves with uniform acceleration of 0.5 meter per second squared indicates acceleration is constant throughout its motion. For 2 minutes time is given. 2 minutes indicate 2 into 60, which is equal to 120 seconds. Find the velocity acquired by car. So what is the velocity acquired by car? Okay, so we, by first equation of motion, we have v is equal to u plus at. So we want u is 0 plus a is 0.5, t is 120, so which is equal to 60 meter per second. Now some of you will say, why sir do you use the first equation of motion? Why can't we use the second equation of motion? Why can't we use the third equation of motion? So see here. See, we can use each and every equation. No problem with that. Some of you will use second equation of motion. So s is equal to ut plus half at t squared. Okay, no problem with that. But from that you will get the displacement. But we want the velocity, right? Okay, no problem. If you find displacement also, no problem, right? So s is equal to ut plus half at t squared. What is u? 0. What is t? 120 plus half a. What is a? 0.5 into t squared is 120 squared. Now which is equal to 120 into 120 divided by 4. So that is 30. So 12 threes are 3600 meter. Right now. So in 2 minutes it will go the 3600 meter. That means 3.6 kilometer. Okay. This is the displacement we got, but they want the final velocity, right? So final velocity, how to calculate? Now you can use first equation or the second equation, that is your choice. So I'll use third equation. V squared is equal to u squared plus 2as. So v squared is equal to, what is u squared? 0 squared plus what is 2 into a? A is 0.5 into s we have is 3600. So this get cancelled and v you will get as 60 meter per seconds. So no problem if you use the second equation, third equation firstly and then calculate the answer, nothing will happen. Initially what you have to do is you have to apply each and every equation. As time passes, as you solve more number of problems like in kinematics, you will automatically get, for this problem we have to use this equation, for this problem we have to use that equation. So I hope this is clear. Now the second problem, write down. We have the second problem, and that is a bus starts moving from rest. A bus starts moving from rest and moves with uniform acceleration full stop. Its velocity after 20 seconds is observed to be 90 kilometer per hour. Full stop. Calculate the magnitude of acceleration. Calculate the magnitude of acceleration. So in this it is given a bus starts moving from rest, right? So initial velocity is 0 given, 0 meter per seconds, and moves with uniform acceleration indicates acceleration is constant over here. Its velocity after 20 seconds, that means time t is equal to 20 seconds, its velocity is given 90 kilometer per hour. Now you can convert this 90 kilometer per hour into meter per seconds by multiplying this into 5 by 18. So we have 1 kilometer per hour. So if anyone don't know what is the conversion of 1 kilometer per hour into meter per second, just write down this. 1 kilometer per hour is equal to 5 by 18 meter per seconds. Okay now. And if 1 meter per second, 18 by 5 kilometer per hour. That is totally simple only. So we have, this is 25 meter per seconds. Now we know final velocity, we know initial velocity. we know the time, we can find acceleration. So use v is equal to u plus at. V is equal to u plus at. So from this, what is v? 25, which is equal to u 0 plus a we want, and t is 20. So if you just find out, a is equal to 25 divided by 20, so which is 1.25 meter per second squared. So this is the answer we have. This is the answer we have. So I hope this is clear, right? So these are the problems, these type of problems you will encounter in kinematics. Now the last problem we'll take, and after that motion under gravity I'll teach. So we have third question, and it is given: a bus driver observes a obstacle at a distance and presses the brakes. If the bus was initially moving along, if the bus was initially moving along a straight line with a velocity of 72 km per hour, with a velocity of 72 km per hour, how much time will it take? How much time will it take for the bus to stop if the retardation due to the brakes is, if the retardation due to the brakes is 5 meter per second squared. Now this is the question given. A bus driver observes an obstacle at a distance and presses the brakes if the bus was initially moving along a straight line with a velocity given, and how much time will it take for a bus to stop if the retardation due to brakes is 5 meter per second squared. So initial velocity of the bus given, right? Initial velocity of the bus given, and that is 72 km per hour. You can convert it into meter per second. I told that. And retardation is given, that is a is equal to 5 meter per second squared. Now we want what is the time at which the velocity of the bus becomes 0. Velocity of the bus becomes 0. So you can calculate time over here by using first equation of motion. But in the same question, I want first question. I'll give. I want what is the distance traveled by bus before it stops. Second question, what is the velocity of a bus at 3 seconds? So these are the two questions, first and the second. You try to solve. This one I will solve. So see here, this is 5 meter per second squared retardation. This is 72 km per hour. So we have the initial velocity is 72 into 5 by 18, which is 20 meter per seconds. 20 meter per seconds, and the acceleration is 5 meter per second squared. So final velocity is 0 we want, which is equal to initial velocity 20 plus a we have is minus 5, because it is in the opposite direction of the initial velocity given. So into t, so t you will get as 20 divided by 5, which is equal to 4 seconds. 4 seconds. So I hope this is clear now. This is 4 seconds which we have. So answer for this question is 4 seconds, but I want this is the first and this is the second question answers. Right, once you got the answer, please comment in the comment box. I'll reply to your comment. Okay. Chalo. Now after this we have motion under gravity. Motion under gravity. So see here. Now in this motion under gravity. So in this I'll take two conditions, two situations we can say. First one is, if I release the ball, and this is the ground supposed to be, if I release the ball, then what will happen? And second one is, if I throw the ball from the ground upward with some initial velocity. So I'll consider this height as same as this height. So if this is capital H, this must be capital H. And here initial velocity we have is 0 meter per seconds, and this is the initial position and this is the final position which we have. Then from initial position to the final position, the displacement is in the downward direction, as you can see. And over here, this is the initial position and this is the final position. So the displacement which we have is in this direction. As you can see over here, displacement is in the upward direction. Here displacement is in the downward direction. Now if I ask what is the direction of acceleration, as this body is always accelerating towards the center of the earth, that is towards the ground, we can say the body's acceleration will always be in the downward direction. Here also, whether the body is moving upward or the downward, the acceleration will always act in the downward direction. And here one thing that you need to remember, and that is acceleration is equal to the acceleration due to gravity, which is equal to 9.8 meter per second squared. Always, right? On the surface of the earth, acceleration due to gravity is constant, and that is equal to 9.8 meter per second squared. And for simplification purpose, we take it as 10 meter per second squared. Unless and until it is mentioned, you always have to consider 9.8 meter per second squared. If it is mentioned that 10 meter per second squared is the acceleration due to gravity, then and only then you have to take 10 meter per second squared. Okay, so over here, initial position, final position, displacement downward, acceleration downward, velocity of the body at this point is in the downward direction. This body, if you throw upward, it will go to the maximum height of h, and at this point final velocity is 0 meter per seconds. Let us consider, we throw the body in such a way that it will go to the maximum height, and at that point velocity is equal to 0 meter per second square. Now 0 meter per second. Now if I ask, can the body have the zero velocity but still the acceleration on the body is acting, right? So that means acceleration is present but the velocity is zero. Is it possible? Is this condition possible? So here, yes, it is possible. As you can see, if you throw the body upward, it will go to the topmost point, and at the topmost point it will have the instantaneous zero velocity. Still, the acceleration is acting in the downward direction. That is the only reason that the body is coming down. If velocity is zero, and at that time if the acceleration also zero, if it is possible, then that body would have float in the air only. But that is not the case. That body will come down with some acceleration, right? With some acceleration. That acceleration is acceleration due to gravity, isn't it? Right now. So we'll find out the three equation of motion for this as well as this. So first equation, final velocity is v. Now here v velocity is downward direction, so you can write minus v is equal to, if you wanted to calculate v value, so don't write negative sign, right? Automatically you will get, if you wanted to find out the velocity, right, don't write negative sign, right, because automatically it will be in the final answer, right? It will come in the final answer. So minus v is equal to, I'm writing everything in the sign convention form. Initial velocity is 0 plus acceleration we have is minus z by, because it is in the downward direction, into time t. Now this time is called as the time of descent. Why? The time required for a body to fall down towards the surface of the earth, right? Whatever time required for a body from a certain height to fall down to the ground, that is called as the time of descent. So over here, time of descent you can have, and that is v divided by g. So this is the time of descent we have. Second equation of motion, s is in the downward direction, so minus h is equal to u is 0, so 1 by 2 into minus g into t squared. That this is also td only. So the time of descent has two formulas. Td is equal to root of 2 into h divided by g, and third equation of motion, v squared, final velocity v squared, that is minus v squared is same as plus v squared. 0 squared is equal to 2 into h minus h into minus g, and as you can see, final velocity we have is root of 2 into g into h. So I hope this is clear to you all. Now for the second diagram, first equation of motion we can write, final velocity is 0, which is equal to initial velocity u plus at, a is minus g, into time t is called as time of ascent over here. What is time of ascent? It is the time required for a body which is thrown from the ground to reach the maximum height. So that is the time of ascent. So time of ascent ta is equal to u divided by g we have. Time of ascent ta is equal to u divided by g we have. Second one, the displacement is h is equal to u into ta plus 1 by 2 into g over here, a over here is minus c into ta squared. So h we have is equal to u into, if you put ta as u by g, you will get minus 1 by 2 g u by g whole squared, and h is equal to, if you just take u by g common, you will get u minus 1 by 2 g into u by g. So this g get cancelled, you will get h is equal to u squared by 2g. So this is nothing but the third equation only, but yeah, we can find third equation also. Third, and that is final velocity 0 squared is equal to initial velocity u squared minus 2g into h, and yes, h we have is u squared divided by 2g. So I hope this is clear, right? So accordingly we have over here the three equations for freely falling body and a body which is thrown upward with some initial velocity. Okay, so the main thing over here that you need to remember is time of descent td and time of ascent ta. Maximum height h over here is u square by 2g, and yes, for a body to go up, time of ascent we have is u by z, and for a body to come down, time of descent we have is u by g, because this u is exactly equal to v. Why we consider that? Because h is same over here, and as you can see, this v is root of 2gh and this u is root of 2gh, as h is same, right? So from this equation 1 supposed to be and this equation 2 supposed to be, from 1 and 2, from equation 1 and 2, we can have v is root of 2gh and u is root of 2gh. So v is equal to u. V is equal to u, right? So we can write time of ascent is exactly equal to time of descent. So therefore total time of flight, what is time of flight? Total time that body is in the air, that is what the time of flight means. Total time for which given body is in air is called as the time of flight, and that is equal to what? Time of ascent plus time of descent. And we know that time of ascent is exactly equal to time of descent when we ignore the air resistance. So therefore time of flight t is equal to 2ta, which is equal to 2 into u divided by g, which is 2u divided by g we have. 2u divided by g we have. So I hope this is clear to you all. Now based on this, we'll do two questions. First question we have, and that is first question, write down: a ball thrown vertically upward, a ball thrown vertically upward from the top of the tower, from the top of a tower with a velocity 10 meter per second, with a velocity 10 meter per second, full stop. The ball reaches the ground, the ball reaches the ground the ball reaches the ground with a velocity 30 meter per second, with a velocity 30 meter per second, full stop. What is the height of the tower? Full stop. What is the height of the tower? So tower height we want, and it is given. So firstly understand the question, right? Understanding the question is very important. Before starting the solution, always try to understand the question very thoroughly. A ball thrown vertically upward from a top of a tower. So here tower is given, and when ball is thrown vertically upward from this top, and let us consider the height of the tower is h we have, okay, with a velocity 10 meter per second. So 10 meter per second, so it will go up, it will reach certain height, and it will come down and it will fall. Okay, no problem. The ball reaches the ground with a velocity of 30 meter per second. So this is 30 meter per second given. What is the height of the tower? So here we want height is how much. So this is the initial position of the ball, and this is the final position of the ball. That indicates we need to find out what is the displacement, isn't it? What is the displacement? And that is equal to minus h we have. Okay, now displacement is minus h. What is the initial velocity? Initial velocity we have is plus 10 meter per second. Final velocity is minus 30 meter per second, and the acceleration a is equal to minus g we have, and that acceleration you can consider as minus 10 meter per second square. Now we know, u we know, a we know, only h we need to find out. Which equation we have to use? Yes, it is the third equation we have to use. So final velocity squared is equal to initial velocity squared plus 2 into a into s. Final velocity is 30 squared, that is minus 30, or the plus 30, same thing. Initial velocity is 10 squared plus 2 into a we have is minus 10 into s we have is minus h. So here 900 minus 100 is equal to minus plus 20 into h. So h we have is 800 divided by 20. So this 0 get cancelled. We'll get 40 meter is the height of this tower. So if you know the concept very thoroughly, right, it is very simple to find out any problem, right? And before writing the solution, always try to understand the question. Okay, so the last question of this session, and after that we'll conclude the session. So write down the question, and this question is: an object is thrown upward with a velocity of 20 meter per seconds. Find number 1, maximum height, number 2, time of flight, number 3, time of ascent, that is TA, number 4, displacement of a ball, in the last second during upward motion. So all these questions you have to find right answer. And maximum height, you can use u square divided by 2g. I'm just giving the hint. Time of flight, you can use 2u divided by g. Time of ascent, you can use u by g. Displacement of a ball in the last second, so nth formula you can use during the upward motion, right? So n you have to calculate total time during the ascent, right? You have to find. If you like this video, then please do comment, do subscribe to my channel. Thank you so much.